right. So, hi everybody. I am here with Dr. Granoff, who has generously offered some time to talk through statistics. And we're going to go through a number of things. There will be a number of videos that you'll be able to see. But Dr. Granoff has been really helpful to a lot of students at GCU. And I know his approach and his style is really helpful in using his word, demystifying statistics. So I wanted to take some time to ask him a few questions and get his perspective on statistics. So welcome, Dr. Granoff. Anything you want to say before we jump in?
Thanks, Rebecca. Hello, everybody. A little bit of my background. I have been doing stats on theses and dissertations for about 40 years. Probably done the results chapter on at least 2,000 projects over the years. And I've taught graduate school for about 25 years, teaching stats, quantitative and qualitative research methods. So I've been at this for a while. My approach may seem almost non-academic because most of the folks I work with are working professionals over 40. Many of them at that point have, professional careers going, and they've got kids and they've got 30 other things, and they're getting their doctorate either for enrichment or to move them up to the next level. So my approach tends to be, let's explain what needs to be done so you can get this done. This isn't to win dissertation of the year. This isn't, designed to be published in a fancy journal article. For most of the folks I work with, the dissertation is a fancy term paper that needs to be done so they can graduate and get on with their life. Right. So with that, we tend to just focus on what needs to be done. And I look, having worked on so many projects, I've kind of learned some ways to teach the material. Because any of you who are teachers, you know that if you give an example and the student goes, huh? You don't use that example again. So having taught this so many times, I've got some ways that I hopefully you'll find helpful as we go through the material.
Awesome. And before we get too far in, I do want to note that Dr. Granoff offers a coaching session. Is that what you call it, on Saturday mornings?
I do.
Your questions. So I'll make that information available in the video description so you can access that and reach out to him anytime that you need to, because he's a great resource.
Thank you.
All right. So I'm going to share my screen because we've talked about a couple of things that we want to share with you. So this looks a little scary. What do we have here? Is this the one we're starting with?
Yes, this will be fine.
Okay. All right.
So how I'd like to start is just go through some of the fundamentals of descriptive univariate statistics. Univariate means one variable at a time, like a unicycle has one wheel. So typically when you're summarizing data, these are some of the statistics that are needed here. You'll notice I've got 5 examples here in the left column. Then I have a sample distribution of scores. Then we have the minimum score, which is the lowest, the maximum score, which is the highest, the range of scores, which is the maximum minus the minimum, the mean or the average, the standard deviation, and then we have the median. And so what I'm going to do is I'm going to walk us through these 5 examples and talk about how the numbers change based on whatever data set we have here. Okay.
And each of the examples is representative of one variable, like the scores from work engagement or the scores from perceived organizational support. Okay.
Yes. So in the first example, everybody has a 10. The lowest score is a 10.
Yep.
The highest score is a 10. The difference between the lowest and the highest is 0.
Right.
The mean or the average, you add all 5 of those up, you divide by 5, you get 10. The standard deviation is 0 because there's no variation in the scores at all.
Gotcha.
And then the median I like to think of the median like the median strip on the highway or the 50-yard line. Half are larger, half are smaller. So when you have 5 scores, the middle score in the distribution is the median. The median is often used when you have groups where there's a lot of differences in value. For example, you usually see the median when you're looking at home values. There might be people that live in a $50,000 home, and there might be people that live in a $10 million home. And you want to say, where is the middle of that distribution?
Gotcha.
So that's the first data set there with 10, 10, 10, 10, 10.
Can I ask a question about median? When
Absolutely.
you figure out that middle number, is that ordered from like lowest to highest, and whatever that middle number is, that's the median?
Yes.
Okay.
And if it's an even number of scores, like there's 10, the
Yep.
median is the average of the 5th lowest and the 6th lowest.
Gotcha. That makes sense.
All right. So that's the first one, 10, 10, 10, 10, 10. The second one is 8, 9, 10, 11, 12. Just a little bit different.
Yeah.
We'll see the minimum here is 8, because that's the lowest.
Yeah.
The maximum or the highest is 12. The range of scores is 12 minus 8, which is 4.
Okay.
The average is still 10. Add those 5 scores up, divide by 5.
Yep.
The standard deviation is 1.6. We'll cover standard deviation in a little bit. And the median or the middle score in the distribution is still 10.
Makes sense. Yep.
In the third sample, we've got 1, 5, 10, 15, 19. The lowest score is a 1. The highest or the maximum is 19. The range of scores is from 1 is 18, 19 minus 1. The average is still 10. Now notice the standard deviation is 7.3, whereas in example 2, it's 1.6.
Right.
The reason the standard deviation is bigger is there's a larger range of scores, which means there's a lot more difference between all the people in the sample. And our pal, the median, is still at 10.
Oh, interesting. Okay.
Now notice the difference between sample 3 and sample 4. We've got that 99 there. Look how that one number changes everything.
Yep.
The minimum's 1. The maximum is 99. The range of scores is 98 from 1 to 99. The mean now is 26. Now, is the average of 26, is that representative of the whole sample? No, it's got this one outlier here that messes up everything. Then you notice the standard deviation is 41.2, which is really big. And we'll go into the definition of that in a little bit. But even though we've got from 1 to 99, the median is still 10.
Still 10. Interesting. Okay.
Now compare example 1 with example 5. The difference is that last number there of 99.
Yep.
The minimum or minimum is 10. The maximum or highest is 99. The range is 89. The mean is 27.8. Is that mean of 27.8 representative of the whole sample? No.
Mm-hmm.
And the median is still 10.
Right.
Rebecca, do you have any questions on this?
No, this makes complete sense to me.
Could you scroll down to the bottom half
See.
with the definitions here?
It's interesting how you can see things change with the different numbers.
Okay, so some of these are pretty straightforward. Just the minimum is the lowest score or smallest. The maximum is the highest. The range is the spread of the scores from highest minus the lowest. The average is, or the mean is the best, usually the best single prediction of a typical score. However, notice that third sentence there. However, 1 or 2 extreme scores can inflate the statistic. That's where we saw when we had the 99s there.
Interesting. And that's why, I might be jumping ahead, but that's why you check for outliers.
You do. You want to see that's actually part of the data set. I was working with one person and somehow their zip code ended up in the age column. So the average age in the sample was like 326.
Right.
It's like when we were teaching my son math in kindergarten. He had 3 bunnies and a duck. And he's supposed to circle the duck because the duck was not like the bunnies. It's that type of a thing. And you'll want to, and particularly in a smaller sample, an outlier needs to be taken care of and either removed, or there's a lot of different things to do, but beware of outliers, I think, at this point. All right. The key thing here is the standard deviation. That's the spread of the scores around the mean. When the scores are similar, which is the fancy term is homogeneous, homo like homogenized milk, they're similar, the standard deviation is small. When the scores are dissimilar, heterogeneous, the standard deviation is large.
Okay.
1 or 2 extreme scores can inflate this number. Now, the standard deviation provides an upper or lower and upper fence around the mean. As an example, if you have a mean of 20 and a standard deviation of 5, plus or minus 1 standard deviation goes from 15 to 25. 20 minus 5 is 15, 20 plus 5 is 25. That's about 2/3 of the scores in the sample. Plus or minus 2 standard deviations, 20 minus 5 is 10, 20 plus 5 is 30. That's about 95% of the scores. Typically in your dissertation, you report the mean and the standard deviation. One way to look at it is if the standard deviation tends to be large, you probably have people that are not all similar in your data set. And you may need to look at it and do some additional kinds of things to look at distributions or outliers or box plots or things like that.
Interesting.
And then to recap the median here, it's the middle score. The median strip on the highway is in the middle. The 50-yard line, half are smaller, half are larger. So Deborah, if you could, or excuse me, Rebecca, if you please go back up to the stuff at the top.
Sure.
So to get a sense of the standard deviation, compare example number 1, 10, 10, 10, 10, 10, and number 5, 10, 10, 10, 10, 99. When they're all the same, the standard deviation is 0 because there's no variation.
Right.
But in sample 5, the standard deviation is 38.9 because it's trying to estimate the whole sample there.
Right, because of that one outlier.
Right.
If that score were removed, then this standard deviation would be 0.
Yes.